Hello everybody, I hope you're all doing well. Root Beer here, looking at question 23, midway through part C of our grade 7 Gauss paper from 2019. Points T, U, V, W, X, and Y lie on square PQRS as shown. Oh, that's quite a diagram they've got there. PT is TU, UQ, QV, VW, and WR, SX, and SY are all the same length. So it looks like we've divided the sides up here into thirds. Okay. What do we want? What fraction of the area of PQRS is shaded? All right, now there's a couple ways I could think to maybe go through this question. Let's draw ourselves a little bit of a picture here. Okay, now I believe this was connected across. These were connected up. Okay. One thing we could do, because we've got this sort of common length, we could give it a name, maybe X or L for length. Okay, so the sides here are 3x. Well, if I've got an x here, I can deduce that this should be 2x, and this should be 2x, and look at that, this will be 2x, and this will be 2x. And what we can see is we can get sort of a nice little right angle isosceles triangle here. And so you'll get 45 degrees here, and 45 degrees here, and a right angle here. But what's more than that is we can also drop down here, and now this is 2x, so this length will be 2x. This is 2x because this was 2x. Now I've got another isosceles right angle triangle, and down here we can find another one. So there's lots of 45-degree angles going on. Okay? Now, I think what they want, they want this, this, and this. Now, the total area in terms of x's, each side is 3x, so 3x or 3x squared or 9x squared is the total area. But if we look at that red isosceles right angle triangle, it's what, 2x and a 2x, and the area is going to be 1/2 base times height, and when all is said and done, now we got 2x squareds here. And then we've got sort of these smaller ones off on the side, which we'll put in purple. Okay. Now, chasing angles around, you can see, this angle here is going to be 45, this angle here is going to be 45, this angle here is 45, and this will be 45. So we get some right angle isosceles triangles as well. Only this time the x is on the hypotenuse, so I can't really use it in my 1/2 base times height calculations. Now, a nice little right-angled isosceles triangle like this is fairly common. And if we know the Pythagorean theorem, we know that if you got the same side, so we'll say 1 here, you get root 2 for the hypotenuse. 1 squared plus 1 squared is 2. Square root of 2 becomes our long side here, right? Okay. Well, no matter what, if the triangle has the same angles, it's just a scaled up or scaled down version of this. So if my hypotenuse is x, how do I go back to these legs? Well, to go from the legs to the hypotenuse, you multiply by root 2. So let's divide by root 2. Right? And so now I can figure out the area of these is 1/2 base times height. And we'll get x squared over 4. Now I've got 2 of them, these 2 purple triangles. Right? So what have we got? Total area of our square here, 2x squared plus 2 copies of x squared over 4. And that should be, well, we can divide the x squareds out. So this is really 2 plus 2 times 1/4 is 1/2 over 9. We can add 2 and 1/2 to become 5/2. 5/2 over 9. We'll get 5/18 when we work it out. So we're looking for a fraction of 5/18, and that gets us answer A. Now that's an okay way to do it, perfectly fine. But if you're a little uncomfortable naming variables, if you're a little uncomfortable working backwards with right-angle triangles, is there another way we might be able to approach the question? Absolutely. Let's give it a try. We'll redraw our picture. So this is one that I personally, I don't usually use this because I find it a little inexact for what I tend to do. But what have we got here? X, X, X. But some of the kids that I go through these contests with on a monthly basis, this tends to be sort of their go-to for these questions. And so we'll divide the sides up into x's. I'm adding in more x's than they've got. And what I'm going to do is I'm just going to sort of divide up the area completely. Okay? And now in this question they're using, they're sort of the smallest thing I see is a nice little part of a square. So what I'm going to do is I'm just going to chop up these little squares here as well. Do it all. Okay. Okay. So I've chopped up my square into nice little pieces. All of these pieces are the same. Right? Now, how many of them do I have? Well, I've got 9 big squares, and each one has been chopped up into 4 bits. So I've got 36 of these little triangles. Okay, that's the total area. I don't actually need to know what it is in terms of x or anything like that. Okay, now I'm going to come along and draw in the shape that they use. Okay, so I got that line, they have this line here, but because their right angles and their 45 degrees are matching up with mine, this picture works out perfectly fine. I'm going to have to erase what I did over here just to make absolutely certain I'm copying their picture. Okay, so what else do we need? This line coming down here. And so I think that's it. Oh no, they went all the way. There we go. Okay. Now, what did they have shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 10 of these little triangles match up with their shaded figure. So what they've got, their shaded area is 10 of these triangles. In total, we've got 36 of these triangles. So how much of the area is shaded? Well, 10 out of 36. Divide top and bottom by 2, and we get 5 out of 18. Just sort of drawing in more lines, breaking the shape down into shapes that we understand and recognize and that are all the same. Okay, so you still get your answer of A that way. Okay, 2 very different ways to do the question. Both work perfectly fine. It's more what you're comfortable with, what you think is going to be faster. Okay, so that does it for question 23. Up next, question number 24. I'll see you for that shortly.